Question number 10. Question number 10 says, show that A1, A2 till AN form an AP where AN is defined as below. Okay. So question number 10, subpart 1. Now here the nth term in the first case is given to us as 3 plus 4n. And we know that now this is 3 plus 4n. Okay. Now the moment we write this, and you have practiced so many examples wherein, and you have seen all my videos which even covers the insightful blend wherein we have combined various topics like arithmetic progression, linear equations and numbers together. So since you would have gone through them, on the side of it I can say that the common difference is 4 here. Let me prove this also. So now can I say T1 is just like saying 3 plus 4 into 1, which is 7. T2 is just like saying 3 plus 4 into 2, which is just like saying 11. What is the common difference here? T2 minus T1. So now the common difference comes out to be 11 minus 7, which is 4. So there is a learning from here. The learning from here is, if the nth term of a series is given to you as an plus b, now here the common difference is a. This is the learning experience from here. So using the same logic for the second part, though you know this is not an objective question. Had it been an objective question, it would have merely taken you seconds to come down. So the moment the nth term is given to you like this, the coefficient of n. Now we know that the nth term will always be represented by a linear equation, which is why we say linear equations, right? Arithmetic series and numbers, they go hand in hand. You can apply the lemma of Euclid also here. The Euclid's lemma, which is let's say the dividend is equal to the divisor into the quotient plus the remainder. So the next question here is, the nth term is 9 minus 5n. So we can use the same logic and we can say that the common difference here is minus 5. But let us solve it. So how much is T1 here? 4. How much is T2 here? So T2 here is n. This is 9 minus 10, which is minus 1. And what is the common difference? Common difference will be T2 minus T1, which comes out to be minus 5. Hence it is proved that the common difference of, when the nth term of a linear series, let's say the nth term here, linear series here refers to an arithmetic series. So if the nth term of an arithmetic series is given to you as an plus b, in that case the common difference of this series can always be inferred as the coefficient of n. Okay, talking about question number 11. So question number 11 says, if the sum for first n terms of an AP is given to you as, so the sum for first n terms of an AP is given to you as 4n minus n square. Now you can say that the sum of an arithmetic series or the sum of an arithmetic progression will always be a quadratic expression, quadratic function or a quadratic equation, dependent on the format in which it has been given to you. Okay, what is the first term? That is S1. Okay, and what is the sum for first two terms? What is the second term? Similarly, what is the third term? What is the 10th term and the nth term? Okay, so can we infer that the first term of an arithmetic series is just like saying sum of the term itself? So the first term will have no sum, because for a sum you require at least two terms. So if I say sum of one term here, that becomes equal to the first term itself, right? So just substituting the value of n here as 1, we get the first term here as 3. Correct? Now can we find out the second term here? We can definitely find out the second term, but for that first we need to calculate S2. So what is S2 here? S2 is just like saying 4 into 2 minus 2 square, which is 4. Now if a series has been given to you, please understand it like this. So the series here is T1, T2, T3 and so on till you have a T10 in between and then the last term as Tn. Now if I want to find out the sum for first term, it is just like saying sum for one term is the first term itself. Sum of first two terms is just like saying what? T1 plus T2. Sum for first 10 terms will be just like saying T1 plus T2 plus T3 and this ends on the 10th term. Similarly, the sum for first n terms will be nothing but T1 plus T2 plus T3 and this ends on Tn. Using the same logic here now, and once we know the formulas and we know that the sum for first two terms is 4 and the first term here was how much? The first term here was 3. So now I am getting the sum for first two terms as 4. That means the next term here should be 1, right? Okay, so the first term is 3 and the sum for first two terms is 4. So from here, can I get the common difference? What is the next term that I am going to get from here? 3 minus 2 is 1, 1 minus 2 is minus 1, minus 1 minus 2 is 3 and this is how you get the series. So can you find out the 10th term here? Yes, you can. The 10th term here would be the first term plus n minus 1 which is 10 minus 1 which is 9 into the common difference which is minus 2 and this comes out to be minus 18 plus 3 is minus 15. And if you wish, you can write down all the terms and then count which is the 10th term also, just to check your answer. So next term would be minus 5, minus 7, minus 9, minus 11, minus 13 and the next term should come out to be minus 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Your answer is correct. And then eventually they are asking you to find out what? They are asking you to find out and the sum and the nth terms. Okay, can you find out the nth term from here? Yes. The nth term would be the first term plus n minus 1 into d. What is d here? Minus 2. So can I rewrite it as 5 minus 2n is the nth term? Let's check it out. So if I pick up the first term, I should get the first term as 5 minus 2 which is 3. If I pick up the second term, so I should get it as 5 minus 4 which is 1. Third term should be minus 1. So nth term you get it from here. Okay. Now, once I have done this question, is there any logic that I can apply from here to here? Had this been, so this was a subjective question which had to be solved like this. But had this question been an objective question, let us see how to attempt such kind of questions. So if I say the sum for first n terms of an arithmetic series, let's say this is given to you as, you know, it will always be a quadratic equation, expression or a function as discussed earlier. Now this will be a quadratic expression or equation of this sort. Why of this sort? Because you know that sum is equal to n by 2 of and you multiply it by something which is inside, which comprises of a constant term and something with n. So you will never get this as ax square plus bx plus c. Here the y-intercept will always be absent. So can I find out the sum for first term here? Yes, I'll get the first term here as a plus b. Can I get the second term from here? Let's see. The sum for first two terms would be how much? 4a plus 2b. And I know that this is nothing but my first term only. So what is the common difference now? The common difference is nothing but what will I get from here? How do I get the common difference? So let's first find out the second term. So sum of two terms is nothing but saying first term plus the second term. You already have the first term, so can I say 4a plus 2b will be equal to a plus b plus t2. So can I get the second term from here? Yes, the second term would be 3a plus b. What is the common difference? Common difference is the second term minus the first term, which comes out to be how much? 3a plus b minus a plus b. Okay, so this comes out to be how much? 2a. So now you can take it as a standard formula. What is the standard formula? This is the standard formula. So if the sum of an arithmetic progression or a series is given to you as an square plus bn, In that case, the first term will always be the sum of their coefficients. I mean the leading coefficient, which is the coefficient of n square, and the sum of the intermediate coefficient, which is the coefficient of n, their sum. So I could have used the same logic here, and I could have said 4 plus minus 1, which is 3, is the first term, and the common difference here will be twice of a, which is the coefficient of n square. So here the coefficient of n square is how much? Minus 1. Twice of this comes out to be minus 2. And what is the common difference that we got from here? We got the common difference as minus 2 only. So here we got the common difference as minus 2, and we got the first term here as 3. You can simply use this logic. Now this is a very handy logic, or this is a very handy method when it comes to an objective question of this sort. Moving on to the next question, which is question number 12. So question number 12. So this is a very, very important concept. Please use it as and when required. Analogously, this was a very important concept that we had discussed here. Okay. So now we are talking about question number 12, which says find the sum of first 40 positive integers divisible by 60. Positive integers divisible by 60. Okay. First 40 positive integers divisible by 6. I'm sorry, not 60. Find the sum of first 40 positive integers divisible by 6. Okay. So first is 6 into 1. Next comes out to be 6 into 2. And the last here comes out to be 6 into 40. Can I take 6 common from here and rewrite it as? Now, since I have to find out the sum, so 1 plus 2 plus 3. Why have I taken 6 as common? Because 6 is, you are taking multiples of 6. So, in every term that you are taking, you will always have 6 as common. So, when you are adding all of them, 6 can be taken as common and then multiplied by the remaining. Now, we know that the sum, so we are finding out the sum. The sum for first n terms is written as n into n plus 1 divided by 2, as we have discussed in our videos earlier. So this will be 40 into 41 divided by 2. How much is 40 into 41? Can I say this is nothing but, which further can be written as 4920. This is the sum for first 40 multiples of 6. Now when I say first 40 multiples, I am basically referring to positive integer multiples only. Moving on to question number 13. Find the sum for first 15 multiples of 8. Now, so using the same logic as discussed here, so if you are saying first 15 multiples of 8, you are basically saying 8 into 1, 8 into 2 and so on, ending on the 15th multiple, which is 8 into 15, and you are supposed to find out the sum for first 15 multiples of 8. Which will be 8 times of 1 plus 2 plus 3 and so on till 15. And then using the formula is n into n plus 1 divided by 2. So which is just like saying, let's say 60 into 16, which is 960. Moving on to the next question, which is question number 14. So it says find the sum of odd numbers between 0 and 50. So question number 14 talks about the sum of odd numbers between 0 and 50. So the point here arises here is, how many odd numbers have you taken? You know that the nth term for an odd number, as we have already discussed in our videos, will be 2n minus 1. You can always find out the nth term. And the sum for first n odd numbers is n square. We are just using what we have already discussed in our videos. Maybe in the introductory video, or maybe while we are solving the questions, and we would have discussed some very important concepts while discussing a particular question. So which is why it is suggested when you are watching the videos, watch them in totality, irrespective of the time stamps which have been given to you. Okay. So how many odd numbers we would have taken here? So can I say 2 into 25 minus 1? Because the last term that I am getting here is this. So what is the sum for first 25 odd numbers is what they are asking for, which is 625. So if I talk about all odd numbers between 0 and 50 and then we talk about calculating their sum, the sum works out to be a 625. Okay, talking about question number 14. No, question number 14 we have already talked about. Question number 15. So question number 15 says, a contract on construction job specifies a penalty for delay of completion beyond a certain date, rupees 200 for the first day, rupees 250 for the second day, 300 for the third day, etc. The penalty for each succeeding day being 50 more than that. How much money the contractor has to pay as penalty if he has delayed the work by 30 days? Okay, so we are talking about the penal amounts. The penal amounts are, so rupees 200, let's say, on the first day. On the second day, if it is, and then every subsequent day, the amount increases by 50 rupees. I mean, the amount increases. So the next day it will be minus 300. So you are supposed to talk about the 30th day. So it says, if he has delayed the work by 30 days, how much money the contractor has to pay as penalty? Okay, so can I find out the 30th term? This is just like saying first term, second term, third term. So the 30th term will be A, which is minus 200, plus N minus 1, which is 29, 30 minus 1 is 29, into D, which is minus 50, which comes out to be, how much is this? So minus 1650 is rupees is going to be on the 30th day. Now we are supposed to find out the sum for all these 30 terms. So which will be nothing but 30 by 2, which is 15. And then the first term and the last term we can add. So when we add the first term and the last term, we get it as, we get this, right? Now when we multiply this, let's see how much do we get. So the penalty that individual, so we are getting the sum as minus rupees 27,750 is what we are getting.